back. My name is Amy Long. If you are here, then you are here for a learning session with Miss Long. So we're learning with Miss Long today. What's up, everybody? I am a teacher in Fulton County Schools, if you did not know, representing at the ATL, South Atlanta. I love our students in Fulton County. We have the best kiddos around, and I'm here today to extend a learning opportunity your way. We are currently in March, which my birthday month, whoop whoop, but we are also in Success Academy. So regardless of the fact that we are out for the coronavirus, it's still really important that the kiddos have this knowledge and we can make this material accessible to them. So I would love today to go ahead and talk to you about adding and subtracting fractions. So before we start, you can download that related student packet by clicking the comments below. This is a fifth grade standard, fifth grade level. I will show you all of that information in just a moment. We're gonna have some frequent breaks within this whole entire lesson to make it as fun as possible. And to go over quickly the materials you may need: a pencil, scratch paper, a good attitude, and your best dance moves. So if you're ready, let's go ahead and look at some objective material. So today, again, we're gonna be adding and subtracting fractions. And I'll let you just go ahead and pause this if you need to look over this really quick. But this is going to be all the information that you would need to know to understand what we're going to be talking about today in this video. So I'll give you a moment to pause this, and when you're ready, we can get going. So we use the standards mastery framework in order to kind of guide our teaching and to ensure that we are teaching to the rigor of the standard and what the test will be expecting of us. So today, when we're looking at this standard, we are looking at the level 3, which is going to be meeting grade level standards. So in order for us today to meet performance standards, we will need to solve word problems involving addition of fractions, including cases of unlike denominators. So add two fractions when they may have unlike denominators by using models or equations to represent the problem. Also, learning target 2 will need to solve word problems involving subtraction of fractions, including unlike denominators. We'll need to be able to use visual fraction models or equations to represent the problem as well. And finally, we'll need to be able to use benchmark fractions like 1/2 and as well as number sense of fractions to estimate mentally and assess the reasonableness of your answers. So for example, recognize an incorrect result like 2/5 plus 1/2 equals 3/7. We know that that can't be true because we know what 1/2 looks like, right? So imagine a circle, 1/2 of what that is. 3/7, we know half of 7 is 3.5, that's 3.5. 3/7 is less than a half. So how can 2/5 plus a half equal 3/7, which is less than 1/2? It doesn't make any sense. So we would need to use our number sense and what we know about fractions and models for us to be able to truly understand what we are learning with addition and subtraction of fractions to meet grade level standards. So with that being said, guys, I'm so ready to get started. I am super excited again to be here, and again, nothing can replace the direct instruction of a teacher. So I'm so excited to be here and offering this to you. So let's get started. All right, guys, so let's do this thing. We're on number 1, which if you're following along in your packet is going to be on page 94. So in grade 4, you guys learned that adding and subtracting fractions is really similar to adding and subtracting whole numbers. So I want you to go ahead and take a look at the first problem. I'll go ahead and read it aloud, and then I'll give you a little time to reflect over it. As you are reading this, or as I'm reading this, I want you to think about ways you can solve the problem. Emiliano needs 1/2 stick of butter to make cornbread. He also needs 1/4 stick of a butter to make apple muffins. How many sticks of butter does he need? So I want you to consider both of these models, and then I want you to try to make sense of the problem. Ask yourself the following questions at the top of the screen. I'm gonna give you about 30 seconds to ask yourself these questions and reflect. All right, so let's go ahead and let's take a look at it together. Let's look at that. Let's actually go back so we can look at these questions together. So what is the problem about? We clearly see that somebody needs some butter to bake with, right? Emiliano does. And we're going to need to add these two pieces of butter together, right, to know how much of a stick of butter we need. That's what we're trying to find out. How much butter do we need in all of the recipes? What information is important about this? Well, we know that we need 1/2 stick of butter. Oops. We need 1/2 stick of butter. That's important. And we need 1/4 stick of butter. And we know that he's making two recipes, so we know that we're going to be adding those two amounts together. So let's go ahead and let's talk about it. If we look at both of these models down here at the bottom, I see that this piece of butter, or this stick of butter, has two pieces in the whole. So that's the reason why the denominator has a 2. This stick of butter over here, he needs 1/4. So I see 1, 2, 3, 4 pieces in the whole, which is the reason why the fraction denominator is the 4 in the 1/4. So if I add both of those together, I can kind of go ahead and estimate or sort of guess how much I think he will need. So I'm wondering, will he need more or less than 1 stick of butter for both recipes? If I look at these pieces of butter, I know how much 1/2 of a stick looks like, which is right here. Well, I know I'm also going to add 1/4 of a stick. Now, 1/4 of a stick is less than 1/2 because 1/2 is right there, right? So if I'm estimating and I'm going to put this right here, I know that for both recipes, recipe 1 and recipe 2, he's going to need less than 1 whole stick of butter. So when I am going ahead to add these fractions together, I'm going to know that my answer is going to need to be less than 1 stick of butter. So I should not have any type of a mixed number, again, because it will be less than 1. All right, so let's go ahead and you could take a moment to reflect again. I want you guys to try to throw a comment down below in the comment section, obviously. And why don't you go ahead and tell me what kind of strategy you would use to solve this problem? How could we add 1/2 to 1/4? So go ahead after you have reflected and sound off in the comments below. Please sound off. Represent your school, and even if you're not in Fulton County Schools, I would love for you to throw a comment below and tell us how you would solve that problem. All right, so we're going to now talk about it together. If you are following along, again, we are on page 94 in the packet, and we've already kind of discussed a little bit about this already. So it says, does Emiliano need more than 1 stick of butter or less than 1 stick of butter for the cornbread and apple muffins? Well, we just said that we know what 1/2 looks like, which is right here. And we know that 1/4 is less than 1/2. So I can see that together, both of these are less than 1 whole stick of butter. So he will need less than 1 stick of butter. And how do we know? We just explained that because 1/4 is less than 1/2, plus another 1/2 would have to be less than a whole. If we're looking at C, do 1/2 and 1/4 have like denominators? Well, if I look right here, what do you think? Those numbers are not the same, so they do not have like denominators. All right, we're on D now. How do you find equivalent fractions? Well, I know that if I have two fractions, like 1/2 and 1/4, and I need to find equivalent fractions, you can kind of multiply the numerator and the denominator by the same thing. So let's say, for example, I want to make an equivalent fraction to 1/2. If I multiply the numerator and the denominator by the same thing, like a 2, 1 times 2 is 2, and 2 times 2 is 4. So 2/4 is equivalent to 1/2. You can even do it again, times 3. 2 times 3 is 6. 4 times 3 is 12. 6/12 is also an equivalent fraction to 2/4, which is also an equivalent fraction to 1/2. So It's as easy as that to find an equivalent fraction. So 4, if we're moving on, 4 is a multiple of both 2 and 4. Write an equivalent fraction for 1/2 using fourths. Well, I'm looking here and I see that we started with a 2 in our denominator and we want to get to 4. So what do we need to multiply times 2 to get 4? Well, the answer is 2, right? So if we multiply something on the bottom to our denominator, we need to multiply it on the top as well. So 1 times 2 is 2. So the equivalent fraction, 1/2, is equivalent to 2/4. Now let's go ahead and move on to F. So looking at F, we see that this equation is kind of already set up for us. We know that based on E, we know that 1/2 is equivalent to 2/4. So we can kind of place that in here. 2/4 plus 1/2 is what? We have 2/4 plus 1/4. 2 plus 1 is 3. And we add, we keep the parts the same. So 2/4 plus 1/4 is 3/4. So he needs 3/4 stick of butter. So if you're following along with us, we are now at the bottom of page 95 in our packet. We are going to find out a little bit more. So we already know, just since basically first grade, that addition and subtraction are inverse operations, right? So if you have 2 parts, you put them together to get your whole, and if you have the whole, you could take away a part and get the other part, right? So they're basically undo each other, inverse operations. So to add fractions, the size of the parts that make up the whole must be the same. Because 1/2 and 1/4 use different size parts, which we see in this picture right here, we see that the 1/2 is a bigger part than a 1/4. We rewrote 1/2 as the equivalent fraction 2/4. And then since 1/4 and 2/4 both use fourths, we combine them to get the sum of 3/4. So 1/2 plus 1/4 gives you 3/4. That same idea is going to work for subtracting fractions. So here's a similar problem. We have 3/4 right here minus 1/2. It says write 1/2 as the equivalent fraction of 2/4. We know that we have to write it as the equivalent fraction because, again, it says the size of the parts that make up the whole must be the same. So all we're going to do is, since we have to subtract the 2/4 right here from the 3/4, you can take away 2 shaded parts from the 3 shaded parts. So we're starting with 3 parts, shaded, 1, 2, 3, and we want to take away 2 of those parts. So we're left with what? We're left with 1 out of 1, 2, 3, 4 parts. So we're left with 1/4. So the key takeaway from this right here, guys, is before adding or subtracting fractions, the fractions must be built from the same size parts of a whole. This means the fractions must have the same denominator or a common denominator. Okay, that's the reason why we had to change the 1/2 into the 2/4, so we can take them away, take away these specific size pieces. All right, guys, so now let's connect and reflect. We are at the bottom of page 95. We're at the bottom of page 95. All right, so it says to write a multiplication equation that shows how the denominators of 3/4 and 1/2 are related. Explain how this equation helps you write 1/2 as an equivalent fraction with a denominator of 4. So that is a mouthful, right? Let's go back and let's break it down to make it easier for us to understand. So write a multiplication equation. So that's the first thing. We know we need a multiplication equation that shows how the denominators of 3/4 and 1/2 are related. So how is 4 related to 2? I know that 4 is a multiple of 2 because 2 times 2 can give me 4. So if I had 1/2, it says explain how this equation helps you write 1/2 as an equivalent fraction with a denominator of 4. So I know that 2 times 2 gives me 4. So if I multiply my denominator times 2, I need to also multiply my numerator times 2. So 1 times 2 gives me 2. So I just created an equivalent fraction. 2/4 is equivalent to 1/2. If I wanted to go a step further, you could even make another equivalent fraction if you want to multiply it by any other number. Say, for example, 5, right? Because just to let you know, that's a 1, right? 2/2 is the equivalent of a 1. If you have 2/2, your 1/2 and 2/2, that is one whole circle. So that's the reason why we multiply the top and the bottom, the numerator and the denominator, by the same thing, because it doesn't change the value of the initial fraction. It's just cutting it into more pieces. So it's showing you that 1/2 right here is also the same as 2/4, right? So if we want to make another equivalent fraction, we just multiply by another 1. Same on the top and the bottom. And so what do we get? 2 times 5 gives you 10, and 4 times 5 gives you 20. We know that if we have 10 pieces over here and 10 pieces over here, right, that's 20 pieces all together. So 10/20, oh my gosh, look, same, twins. They are all equivalent fractions. So let me show you one last. We have 10/20 can be equivalent to 2/4, which is also equivalent to 1/2. They're all equivalent fractions. So isn't that awesome? We just learned how to create an equivalent fraction. Awesome. It's time for a dance party. So get your dance pants on and let's get going.
Trash it, change it, melt, upgrade it, charge it, point it, zoom it, press it, snap it, work it, quick erase it, write it, get it, paste it, save it, load it, check it, rewrite it, start it, play it, load it, rip it, like it, drop it, zip and zip it, lock it, fill it, code it, find it, buck it, fill it, code it, lock it, suck it, fill it, code it, find it, buck it, fill it, code it, lock it, scroll it, find it, code it, find it, buck it, fill it, code it, lock it, suck it, find it, code it, find it, lock it, suck it, fill it, code it, find it.
Wow, that was crazy. Dance party over. All right, so I hope you guys had a little bit of fun and were able to break it down a little bit. So let's move on to our next section of our lesson, which is adding fractions with unlike denominators. So I'm going to go ahead. If you are following along in the packet with us, we are on page 96 now. Again, you can download that packet in the link in the comments below. There's a PDF file there. You can just print it off and follow along with us. So let's go ahead and look at this second problem, and it is a problem about Jenna. So Jenna spent 1 2/3 hours mowing the backyard. After taking a break, she spent 3/4 of an hour mowing the front yard. How much time did she spend mowing the whole yard? So I want you to go ahead and try to make sense of the problem. So asking yourself these questions at the top, I'm going to give you about 30 seconds to get your thoughts together, and then we're going to discuss it in a moment. All All right, so let's go ahead and let's talk about it. So what is the problem about? Well, we know that Jenna spent some time mowing the backyard, and she also mowed the front yard. So we want to know how much time she sort of spent mowing the whole yard. So it's about a girl that's mowing the lawn, and we need to just know how much time she spent mowing the front and backyard together. And that's exactly what we're trying to find out, the amount of time how many hours it took her to mow the front and backyard. What information is important? Well, the amount of time, right? We know we're going to need to add, obviously, how much time it took for the front yard and the backyard. It looks like for the backyard, she spent 1 2/3 hours. And after taking a break, it looks like she spent 3/4 of an hour mowing the front yard. So 3/4 of an hour mowing the front yard. How much time did she spend mowing the whole yard? So the front yard and the backyard together is the whole yard. So that's what we are looking for. So let's go ahead and move on. Hopefully you are following along and sort of thinking along the same lines that I am. So if I'm just thinking of that, let's just kind of think of a model of what that might look like in our head. 1 2/3 hours. Well, I automatically, when I think of hours, I think of a clock. So 1 whole hour, and then 2/3 will be in this one. I know that if thirds is my denominator, then I'm going to need to split this into thirds and also this. And these should obviously be 3 equal parts right here. So I'm going to go ahead and shade and represent my 1 2/3 hours. So here's my 1 whole hour that I represented, and then 2/3. So 2 is my numerator, that's my parts, over thirds, which means I have 3 parts in my whole. So this right here represents 1 2/3. Let's write it down here. Oops, highlighter. 1 2/3. All right. And then it says after taking a break, and let's go ahead and label that. That's our backyard, right? Plus the front yard. This is how my brain is thinking if I'm just breaking this down. And then 3/4 of an hour. Well, I think of a fourth, obviously. And then I want to go ahead and shade that in. So 3/4 is 1 2 3/4. So I guess now, if I look back at what I have and label it, here we go. I know that I want to put these pieces together, but just like I learned in the last problem, I can't do that until I have what? The same size parts in my whole, remember? So with that being said, we need to get, let's see if you can guess it. Common denominators. Right. You're awesome. I know you got that. So common denominators. So let's move on and let's see sort of how a model, if we can picture it. We are still on page 96. Actually, go ahead and take a moment and reflect, if you would, please, before we move on to the model. What strategy would you use? You know, I showed you my strategy, how I'm kind of thinking about doing it, is adding it together using a model, then getting common denominators and adding from there. So what would you use? Take a moment to reflect, and then sound off in the comments below. Again, even if you are not a Fulton County student, you are a 5th grade kid and you are trying to, learn how to add and subtract fractions, we would love for you to join us. This is super fun and an exciting new experience for all of us. So sound off below, guys. What strategy did you use to solve that problem? So now we're going to move on. Since we have sort of commented and got our ideas out, let's see what it would look like in picture form. So if we're using a model, it says you can picture the fractions in the problem using models. These shaded parts represent time spent on the backyard, which is 1 2/3 hours, which is here, the pink, and the front yard, 3/4 of an hour, which is here in the blue. So we see our model, right? The sections needed to be divided into the same size parts to add. That's just what I was just saying. Use dashed lines to divide the fraction models into 12 equal parts. That works because 12 is a multiple of both 3 and 4. So if we are doing our multiples, like our multiples of 3 and 4, it'd be 3, 6, 9, 12, and 4, 8, 12. The first one they have in common is 12. That is the least common denominator that we would use. So since we had 1, 2, 3 parts in here, we're going to need to make this 3 into a 12. And we have 4 parts, 1, 2, 3, 4 parts. We're going to need that, make that 4 into a 12. So it's kind of like, what do we need to multiply times 3 to get 12? And what do we need to multiply times 4 to get 12? And then it's really going to sort of be like this, right? So we would need to multiply our numerator and our denominators by the same thing. So let's do that over here where we have a little bit more room. Let's look down here. Look how they did it. They changed it and they split it into 8/12. So let's look how that works. If we have our fraction 2/3 and we want to make that into 12ths, we know it's thirds. We want it to be 12ths. We know we have to multiply 3 times 4 to get 12. If we multiply 4 on the bottom on our denominator, we need to multiply 4 on the top, because remember, that's just like multiplying by a 1. That doesn't change the value of this. So it's going to give us an equivalent fraction. So 2 times 4 is going to be 8. So that's how they got 8/12. We had 1 and 8/12. And then if we're going to do 9/12, because remember, we need the same size parts to add, we can take our 3/4 up here, and we want that to be 12ths as well, right? So they can be the same size parts. So what times 4 gives you 12? The answer would be 3. 4 times 3 gives you 12. So if we multiply 3 on the denominator, we have to multiply 3 on the numerator as well, because again, that is a value of 1, 3/3. That would look like this. 3 pieces, and then all 3 are shaded. That's one whole. That does not change the value of this 3/4 if we multiply it by it. So 3 times 3 is 9. So again, that's where they get the 9/12 of an hour from. Then if we go ahead and add that up, this is kind of a little bit of a mess, right? But here, let's erase this over here. All right, just get excited. This is so fun. I love math, don't you? So if we have our 1 and 8/12 right here, plus 9/12, we can add that up, right? And that's going to be 1. And then we have 8 plus 9, which is what? 17. And then we keep our denominators the same, 12ths. Well, I see that 17 is bigger than 12, so that's a mixed improper fraction. So how many times can 12 go into 17? It can go in 1 time. We would have 5 left over, and we're going to keep our 12 on the bottom. And then we can't forget about this additional 1. So now we need to simplify, and we have 1 plus 1 would give us 2 and 5/12. And that's how you would kind of combine those. You can also model it down here, guys, if you look, using a number line. And I really like this visual model as well, because if you can see, let's zoom this in. It says the number line is divided into 12ths with a point at 2/3. So here's one whole, right here. So since there are 12 pieces up here, there's 12 parts in the whole. Down here in one whole, there are, count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 parts in that whole. So there is a point at 1. So here's 1 and 2/3. So that's 1 and 2/3 that it took her to 1 and 2/3 hours, that it took her to mow the backyard. And then we're adding on the 3/4 of an hour that it took her to mow the front yard. So let's label our number line and just take a look at how that information is helping us. So right here, from 0 to 1 2/3, that is the amount of time that she spent mowing, again, the backyard. And then that's why it says you need to hop 3 more, jump 3 more over 3/4 of an hour. And 3/4 we know is the same as what? Right here, 3/4 is the same as 9/12. So it says jump right 9/12. So we're here at 1 2/3, and we're going to jump 1, 2, 3, 4, 5, 6, 7, 8, 9/12 over. So where did we fall on the number line? Like, what does this point right here represent? If you notice, we're already at 2. So again, 2 is our whole number. And then 1, 2, 3, 4, 5. And our whole part is 12. And look, guys. Ooh, I know you got this. Look at this. Doesn't that make you feel good when your work checks out? You're awesome. So let's connect and reflect. Guys, we're almost done with this part. If you're following along, it again is on page 97 in the packet. So let's answer a couple of questions. And we've already really talked about a lot of these. Are 1 2/3 and 3/4 made of the same size parts? The answer is no, they are definitely not. We know that because right here, if we look at the denominators, we can see that 1 2/3 is made up of thirds and 3/4 is made up of fourths, which are not the same size parts. A third would look like this or like this, and a fourth would look like this or this or that. Anyways, so definitely not the same size. So look at the models on the previous page. What is a common denominator of 1 2/3 and 3/4? So we're looking for the common denominator of these two numbers. The denominators are down here. So let's look back. Whew, this is a big mess, right? Let's erase so we can have a clear page and look. All right. So what do we say the common denominator was going to be? If we look at our model here, we see that they took the thirds and the fourths and they split them both into what? 12ths, right? So we can put them together. So the common denominator of 1 2/3 and 3/4 is 12ths, right? Excellent job, excellent job. So let me get caught up in my teacher manual, make sure I'm on the right page. All right, here we go. So you can find this common denominator without a model. We could just write a multiplication equation that shows how the denominators of 3 and 4 are related to 12. And off the top of our head, we should be able to say what? 3 times 4 equals 12. And that's how they are related. So let's use this common denominator to find an equivalent fraction for 1 2/3 and 3/4. So remember, to find an equivalent fraction, we multiply the numerator and the denominator by the same number. So in this case, we want to get 12ths because we want the common denominator, right? We just determined that 12ths is the common denominator. So 2/3. Let me zoom in for it. 2/3. We're going to multiply that times 4 to give us what? 2 times 4 is 8. 3 times 4 is 12. So that whole mixed number would be 1 8/12. And then we also want this to be in 12ths as well, right? So we can have common denominators. So 3/4, we would need to multiply times what to get 12? 4 times 3 gives you 12. And again, we need to multiply times a 3 on the bottom. That means a 3 on the top in our numerator, that 1. and 3 times 3 is 9. So again, we have our numbers that we get to add together, and that would be using equivalent fractions on number 6. Using equivalent fractions, what is the sum of 1 2/3 and 3/4? Well, this is equivalent to this, right? We just determined that. And 3/4 is equivalent to 9/12. So let's see. This is easy. We're just going to put it together. So 1 2/3, the equivalent for that would be 1 8/12. And then the equivalent for 3/4 is 9/12. So what is the sum? That means we're adding. And so again, here we go. We're just adding it together. We have 1 here, 8 plus 9, 17, 12. We keep our denominators the same. When our numerator is larger than our denominator, we just ask ourselves, how many times can the denominator go into the numerator? And we know that 12 can go into 17 one time. There will be 5 left over if we subtract 12 from 17, right? That gives us the 5. And then 12 is in our whole, how many parts we have. Okay, and then again, we can't forget about this one that we had here, because 1 5/12 came from the fraction part. Okay, so we have 1 plus 1 5/12, which makes 2 5/12 for your final sum. And again, guys, that's exactly how you add fractions with unlike denominators. You have to first find common denominators. So amazing job. That was some tough work. But you are really putting forth the effort. I'm really proud of everybody taking this opportunity to better your brain. You guys are awesome. So coronavirus not stopping us. What? So let's do our final part of this, okay? So now we are on the applying portion of our step. And we are on page 97. Again, if you are following along, you can pause to complete this and then kind of play back to check your answers. Or if you also like this, sort of guided practice where I'm doing it with you, then, or we're doing it together, then, stay tuned and let's get started. So here we go. What is 1 1/6 plus 2 3/8? Well, when I look at this, I first of all notice that both of these fractions have unlike denominators. They have unlike denominators. So I need to get common denominators. That's the first step, right? So I want to go ahead and do that. I have 1/6 and I have 3/8. Well, 6 and 8, if I am thinking of multiples, let's see, 6, I'm just going to count up 6, 12, 18. What is the next one? 6 times 4 is 24. All right, and we'll stop there. And for our 8, let's do 8, 16, and then 24. And then take a look. The least common denominator is going to be 24. So I know that I want to get these. I'm going to set up a multiplication problem. And I want to get both of these. The common denominators are going to be 24, right? So the golden number that we're looking for is 24. All right. So I ask myself, what do I need to multiply times 6 to give me 24? Well, I did 6 times 1, 2, 3, 4. 6 times 4 gives me 24. If I multiply the denominator times 4, I need to multiply the numerator times 4. That gives us our value of 1. It does not change the value of 1/6. It makes an equivalent fraction. So 1 times 4 is 4. So 1/6 is equivalent to 4 24ths. All right, now let's move on to our next portion, our next fraction. So we had 3/8 right here, remember? We need to make that common denominator a 24 as well. So I ask myself that same question. What times 8 gives us 24? 1, 2, 3. 8 times 3 gives us 24. If we multiply 3 on the bottom, we need to multiply 3 on the top. That gives us our value of 1. It doesn't change the value of 3/8. It gives us an equivalent fraction. 3 times 3 is 9. So 3/8 is equivalent to 9/24. So let's go ahead. Now that we have our common pieces, our common denominators, we can add all of this together. So I'm going to go up here. Hopefully you have a little more room on some scratch paper than I do. I'm going to go up here and kind of follow along up top, okay? So let me erase my multiples. All right, so let's put it all together now. So our original problem is 1 1/6. So we're going to keep the whole number 1, but we're going to take our equivalent fraction of the 1/6, which is 4/24. Plus 2 is my whole number here. And 3/8, the equivalent fraction of 3/8 is 9/24. Okay, so first I can add my whole numbers. So 1 plus 2 is 3. Next, I add my numerators. 4 plus 9 is 13. And then I keep my denominators, those common denominators, the same into 24ths. So what is 1/6 plus 2 3/8? The answer, the sum, is 3 13/24. So if you got that, give yourself a check and a smiley face. And if not, hopefully you kind of have a better understanding of why the sum is that right now. We had to, again, get common denominators of 6 and 8. And the least common denominator for that is 24. All right, so let's move on to number 9. Hank practices 2/5 of the words on his spelling list on Monday. He practices another 1/2 of his list on Tuesday. How much of his spelling list has Hank practiced so far? Well, first of all, I'm so proud of Hank for practicing his spelling list during the coronavirus. I really am. I really am so proud of him. So guys, let's go ahead and let's see what we need to do. What is important? The important information is that he practices 2/5 of his words, right? 2/5 on Monday. He practices another 1/2 of his list on Tuesday. So we know that he's practicing these spelling words. He's practicing some on Monday and some on Tuesday. So how much has he practiced so far? Let's take those two amounts and let's add them together to get the total amount. So right now, just off of a glance, our problem is going to be 2/5 plus 1/2. So how much of his list has he practiced so far? We know our first step should be what? We need to get a least common denominator. So again, let's go ahead and list it out. Count by twos. 2, 4, 6, 8, 10, 12. Count by fives. 5, 10. Whoop, we can stop. That was a quick one. So 10 is our common denominator in this case. So let's go ahead and let's set our problems up. We have 2/5. We know we need to get that denominator to a 10. What do we need to multiply 5 by to get 10? 2. If we multiply 2 on the bottom to the denominator, we have to multiply 2 on the top to the numerator. That's our value of 1. It doesn't change the value of 2/5. It just makes an equivalent fraction. So 2 times 2 is 4. So 2/5 is equivalent to 4/10. Now, let's take the second part of the fraction, 1/2, and we need to get that equivalent, we need to make an equivalent fraction as well for that with the common denominator of tenths. So, what do we need to multiply 2 by to get 10? And we know that it's 5. 2 times 5 gives us 10. And if we multiply 5 on the bottom, we need to multiply 5 on the top. Again, that's that value of 1. It doesn't, you gotta say it with me, it doesn't change the value of 1/2. It just makes an equivalent fraction. So 1 times 5 gives us 5. So 1/2 is equivalent to 5/10. Now let's add them together. So we have both of our equivalent fractions that we're just going to add together. So really, it's just the same. This and this is going to be the same as 4/10 plus 5/10. It's equivalent. 4 plus 5 gives us 9. Keep our values the same on the bottom, our denominators and tenths. So how much of his list has Hank practiced so far? Hank has practiced 9/10 of his list so far. That would be the complete answer that I would expect from you, because you guys know I love a complete sentence. All right. So, wow, we definitely need another dance party. It is about time, you guys. We have already been through 2 lessons so far. This video is going to sort of equate to about 4 to 5 days of instruction, depending on how much you go through in a day. I know that this is kind of heavy work, and I expect you guys to kind of take your time, but also to sort of try to absorb as much of this information as possible. All right, so let's have a little bit of fun and let our brains rest for a minute, and I'll see you guys back in a minute.
I'm always flexing.
I see y'all out there, party animals. It is now time to get to our final section of this lesson. We are adding fractions. So now guess what? It's time to subtract fractions. I want you to go ahead and make sense of this problem. Again, you're going to be focusing on these 3 questions at the top. I'm going to give you about 30 seconds to do that, and then we will come back together. All right, guys, so let's talk about it. The problem. Gavin's water bottle has 1 3/8 cups of water. He drinks 1/2 cup. How much water is left in the bottle? So what is the problem about? The problem is about a guy who has a bottle of water and he's drinking some, and then we want to know how much is left, right? So we are trying to find out how much water is left in the bottle. Right there, it says it. What information is important? Well, we need to know how much he starts off with and then how much he drinks to know how much is left, right? So we have our important information. So it looks as if we have 1 3/8 as our whole, and we are taking away the part of 1/2 to find the other part of what is left. So we have this amount right here, 1 3/8. So we're going to take out that 1/2 and then see how much is left. So I want you to go ahead and take a moment in the comments, guys, to think about what kind of strategy you would use. How could you solve this problem? Again, if you have your packet, we're on page 98. Go ahead and sound off in the comments below. You can just label it problem 3, and the strategy I would use is, or I'm having trouble with, or I don't understand, or an effective strategy you could use is. All right, so let's move on and let's kind of picture this problem in our head, and then look at a visual model. The water bottle is shaded to show that it has 1 cup plus 3/8 of a cup of water in it. 1 cup is equivalent to 8/8 of a cup, and the bottle has 11/8 shaded. So that is a mouthful. So again, the word problem originally says that his bottle has 1 3/8 cups in it. So it says again right here that 1 cup, which is the whole 1, and then plus the 3/8 of the cup, which is the fraction part of the mixed number. Since this denominator right here is 8, we know that in this whole 1, the fraction part will be 8/8, right? So what they did is they made this right here the 1 cup, and it's 8 little parts because there are 8 parts in our whole. So 1, 2, 3, 4, 5, 6, 7, 8. Each part is 1/8 of a cup. That's a unit fraction, sum of unit fractions, right? Each of those little units makes up a whole. And then we also have the 3/8 on top. So if we have 8/8 down here and then we have 3/8 up here, all together, that's 11/8, right, inside of our water bottle. So again, that's why it's saying that the bottle has 11/8 shaded. And look how they represented it here, 11/8. And then look how I represented it here. Same thing. It says, again, Gavin drinks 1/2 cup or 4/8 of a cup. So we have to remember that if we are adding or subtracting, remember we need those common denominators. So we're working with 8s up here, right? All of these are 8s. It said he drank 1/2 of a cup. So how can we make 1/2 into 8s? Well, we know that half of 8/8 would be 4/8, right? So just take away 4 of the shaded parts of the bottle to show how much is left. So 1, 2, 3, 4, those 4/8 or the 1/2 can be taken away because that's how much he drank. And then you just count right here to see how much is left. So again, we had the whole minus a part is going to give us what is left, the other part. And there are 1, 2, 3, 4, 5, 6, 7, 7/8 left. So we had 11/8 minus 4/8 equals 7/8. And again, we had, if you have to look, guys, at the whole piece, right? So we have so many equivalent fractions going on. 11/8 is also equivalent to, remember, 1 3/8. And then the 4/8 is equivalent to that 1/2 that he drank, right? And then our answer still, the difference is still 7/8 because the equivalent fraction right here, the common denominator, guys, is that 8th. So I just want you to kind of see how all of that is related, that this equation right here is equivalent to this equation right here. Like these are the same thing, just written different ways. If you are looking down here, at the bottom, it says the number line below is divided into 8s, 1/8, with a point at 1 3/8. So why do you think that they split the 1 whole into 8 parts? Here's 1 whole right here. Well, again, up here, 1 whole was 8/8. Do you guys hear Lucy running around, my puppy? So they split it 1, 2, 3, 4, 5, 6, 7, 8 parts in that 1 whole. And we had here how much was in the whole bottle. 1 3/8 right here. That's how much was in the whole water bottle when it was full. And then remember, he drank 4/8, 1/2. So 1, 2, 3, 4. And then this is the part where we are right here. So where are we at? 1, 2, 3, 4, 5, 6, 7, 7/8. Right? That's how much is left. And that's what we did. 1/2 is equivalent to 4/8. 4/8 is 4 1/8 on the number line. Start at 1 3/8 and jump left 4/8, and that's what we did. We started at that, we started at that mixed number, 1 3/8, and then we jumped back 4/8, or the 1/2. So let's connect and reflect. So estimate the amount of water left in Gavin's water bottle. When we estimated, guys, we saw again that we had the 8/8, the 11/8 initially, and then we took away 4/8. So our estimate would kind of be a little less than 1 whole, 7/8. If we look at the picture and model it on the previous page, why is 1/2 rewritten as 4/8? So let's look. Why did they have to rewrite this 1/2 down here into 4/8? Do you guys remember? Because remember, there are 8s in our whole up here, and we have to have common denominators, so we had to write the equivalent fraction. So they took the 1/2 and they multiplied it by what? 4, right? And then 1 times 4 is 4. So 1/2 and 4/8 are equivalent fractions, right? All right, use the number line on the previous page to rewrite 1 3/8 as a fraction greater than 1. Then use it to write a subtraction equation with equivalent fractions. All right, so if we look at a number that's greater than 1, that could be a mixed number. So 1 3/8, if we want to write that as a improper fraction, what I do is I do 1 times 8, which is 8, plus 3 more, that's 11. And then I keep my same denominator, so that would be 11/8. So 11/8 minus what? 4/8. That's how much he drank. And then how much would that be? 11 minus 4 is 7. Keep your denominators the same at 8. So why was it helpful to rewrite 1 3/8 as a fraction greater than 1? Well, it would have been really hard to subtract 1 3/8 from 1/2, right? It's way easier, or even 4/8. It would have been way easier to subtract 11 minus 4 than do 1 3/8 minus another number or a fraction. So using those improper fractions really help us just kind of streamline everything and just make it a number minus another number, and simply just do it that way. And then at the end, if we need to, we can always change it back to a mixed number. All right, guys, explain how to subtract 2 fractions with unlike denominators. Well, guess what? It is exactly the same thing as adding fractions, right? So we are going to, number 1, make sure that they both have common denominators, the least common denominator. We're going to add the 2 values, or, well, not add, we are going to subtract the 2 values. And then we're going to keep our denominators the same, right? We want to subtract our numerators. And then keep denominators the same. And then, of course, for the end is always to simplify. That means if we had a improper fraction like 24, and then our bottom number is smaller, like 13, we could say how many times will 13 go into 24, and that would be 1 time. And then what would be left over, and that would be 9/13, like that, 1 and 9/13. So we can kind of simplify. But let's move on, guys. Last part. We are really pushing through. This is the last part, okay? So with subtracting fractions, let's use what we just learned about subtracting fractions with unlike denominators to solve these problems. Show your work on a separate sheet of paper. So again, this is the part in the video where you can choose to pause the video and then complete it on your own and come back and check your answers. Or you can just keep on watching and we can do this together. So make your choice and get your papers ready, and let's get started. All right, so what is 7/8 minus 1/2? So what are our first steps? We know that we need to get the least common denominator because we're looking right here and they are not the same. So 7/8, 1/2. Let's set up a multiplication problem because we know we need to get those common denominators. Well, I already see this is so easy. When you look at the bigger denominator and the smaller denominator can go into it, this is a multiple. Let's just choose that denominator, the larger denominator. So 8 times 1 gives us 8. That means we could just multiply 7 times 1 because that's the value of 1. Doesn't change it, just gives us an equivalent fraction. So 7 times 1 is 7. Now let's make 2 into 8 so we can have that common denominator. 2 times 4 gives us 8. Since we multiplied 4 on the bottom, our denominator, let's multiply it on the top. That's again our value of 1 to give us our equivalent fraction. 1 times 4 is 4. So now we can subtract our two equivalent fractions. So 7/8 minus 4/8. Let's look at our numerators first. 7 minus 4 is 3. Then keep our denominators the same at 8. So what is 7/8 minus 1/2? The difference is 3/8. All right, I love this iPad, you guys. Loving being able to change the colors so easily, and I hope it's easy for you to kind of view it this way as well. So let's go ahead and move on to the last one. I'm going to go ahead and erase this so we can have a fresh start. Emily's living room is 2 5/6 feet wide. The window in her bedroom is 1 1/3 feet wide. How much wider is the living room window than her bedroom window? Okay, so we are comparing the length of two windows, the widths of two windows actually. So we have the living room window, which is larger, and then the window in her bedroom, which is obviously smaller because 2 feet is greater than 1 foot. So let's see how much more, because that's what it's looking at. It says how much wider is the living room window than her bedroom window. So we need to subtract these. That'll be 2 5/6 minus 1 1/3, right? What a wonky 3. Let me change that. There we go. Now, what do we know we need to do before we even try to subtract these? We need to get common denominators. I think it's going to be pretty easy because 6 and 3 are related because 3 is a multiple, well, 6 is a multiple of 3. So let's go ahead and just change those up really quick, okay? So 5/6 is already the same. It already has a 6, so we don't even need to change that one. It's good. We just can go ahead because all we would do is multiply 1 over 1 and get 5/6, right? Same thing. 1/3, we do need to change that to a 6th. So in order to get that to a 6th, we need to multiply 3 times a 2 to get 6. If we multiply 2 on the bottom, let's multiply 2 on the top to keep our value at 1. 1 times 2 is 2. So that is our equivalent fraction. All right, guys, so let's put it all together now. So we have our whole number right here, 2. And we have 5/6 minus 1. And then the equivalent fraction to 1/3 is 2/6. We see that right here. And then we could go ahead and do our whole numbers first. 2 minus 1 is 1. And then we do our numerators. Look at our numerators. 5 minus 2 is 3 over our denominator, 6. Okay, and if I look at that, I actually know that 3 can go into 6. So 3 can go into 6 2 times. So if I look at that, what that looks like, I have, this is a little uneven. Let's pretend these are all equal pieces. 3/6, 1, 2, 3 is the same thing as 1/2, actually. So 1 3/6 is the same thing as 1 1/2. So if we look back at our original problem, how much wider is the living room window than her bedroom window? it is 1.5 feet wider. That would be the answer. All right, guys. So I hope that you enjoyed this lesson. I hope that you really worked your brain out. I'm really proud of everybody again for putting in all this extra work. And I hope that you have this new knowledge now. You are awesome. And again, guys, nothing can replace a teacher being there with you. But I'm so glad that I can offer this opportunity to you. And hopefully I'll see you guys in the next one. See ya. Bye. What? You guys are awesome. You did it. So listen, I know everybody's super busy, but if you want additional practice and you just really want to push yourself, there is some additional information included in this packet below, in the link below, on pages 100 to 103 in your packet. There's just some additional practice using addition and subtraction of fractions with unlike denominators. So again, thank you so much for joining me, and I'm so happy that you were here. Don't forget to wash your little cute baby hands and your cute adult hands, and yeah, stay safe out there. I guess I'll see you guys next time, all right? See ya!